computer. Hello, everyone. My name is Umang Patel. I'm going to talk about Lab 6 sensor board and closed loop current control from PV inverter. My team members are Andy, Eric, and Tone. Tone will talk about the schematic.
Hello, my name is Tuan Nguyen, member of Group 7 in the Junior Design. I'm talking about the schematic of PCB design. This slide is a draw of schematics. It's based on this schematics, we calculate the gains equal to 1 plus 2R1 over R gains equal to 1 plus 2 times 100 kilo ohm over 200 kilo ohm is exactly equal to 2. So based on this one, we can calculate the cutoff frequencies value too, and it's a formula for that. And after all, we end up with a cutoff frequency is 1591 Hz. So my member friend Eric can talking about the actual PCB board.
Hello everyone, my name is Eric. We'll be talking about the PCB design layout. As you can see on the board, left image on the slide, the three sources are placed beside each other. I've tried to isolate the components that are connected to current sensors and voltage sensors, as well as place the capacitors that are connected to the power source on each of the integrated circuits. On the right-hand side of the slide, you can see the magnified J3 pin labels. From left to right, they're labeled as the current sensor on the left, the ground, V negative, V positive, ground, and the voltage sensor. Next slide. On this actual PC board design, you can see that the C99 are placed on the upper left-hand side of the board with two capacitors placed in parallel of each other to add the capacitance for better filtering. Below it's the R167 for the 1 kilo ohm resistor. The C130 is also used for the filtering, C133 as well. On the right side, you can see the R153, where two 100 kilo ohms resistors are placed in series instead of one. This change was made to improve the gain of our design. Next slide.
So this is the testing of our board in oscilloscope. As you can see, the current sensor is in yellow line and voltage sensor is in green line. The current sensor responds to the change in resistors, resistance in the resistors box. If we increase the resistance, the current will decrease, and if we decrease the resistance, the current will increase. Next slide, Andy will talk about the closed loop control system setup.
So pins 40 through 37 are connected to the EPWM interface pins on the control board. Pin 29 on the launch pad is connected to the current sensor. The inductor is connected to VPO sensor 2, and the capacitor and resistor block are connected to VPO sensor 1. The ground pins for this are 22, 20, 62, and 60.
So for the result of our closed loop control system, we used MATLAB code Simulink 5.2, and we got the result as shown in the graph on the right. It is a perfect sinusoidal waveform with 60 Hertz. V peak to peak is 14.7, and we use the IREF as 0.5. We also tested the open loop control system from our previous Simulink from 5.1, and this is our project. Thank you very much.
Thank you very much.